I'd like to right now go through some of the most commonly missed questions on your quiz. 6.5 through 6.8 quiz, the one you took yesterday. Problems 5, 8, and 10 are the three most commonly missed questions, not only by your class, but by the other class. So, we need to talk about it, especially like number 5. Guys, this one I would have hoped would have been a little easier, and I think once we go through it may be. But use a graphing calculator to solve. Okay, so right now close your Chromebooks. Okay, we don't need those open at all. All right, so you should be, except for you. Okay, you should be able to kind of look through this and recognize whether or not you missed this one or not. Okay, if you've already reviewed your stuff. Okay, so right here, y equals, or natural log of 2x equals e to the x minus 3 power. Okay, if we're using our graphing calculator, we're putting that in y equals, or y sub 1 equals, and y sub 2 equals. Okay, so we put those into our graphing calculator. I want you to put them in right now, please. Hey guys, there are like 5 or 6 different versions of this question out there. And second, this is one I made up. So I didn't take one of those versions. So it's kind of like it. I'm not going to do the exact problems for you. All right? So, but the reality is, I mean, you put that into your y equals menu, you hit graph, and you get a cool little picture that looks like that. If your picture doesn't look like that, either you plugged it in wrong, or you're not zoomed to standard viewing window. Okay? And then if you want to find out where they intersect, in this case it looks like they intersect twice. But if you want to find out where they intersect, you go second, calc, or second trace, which is calculate, and option 5. First curve automatically brings me to y sub 1, second curve is y sub 2, and then our guess, you need to move your little cool guy cursor looking thing closest to the point of intersection you want to figure out. So I'm going to hit that one first. That one gives me an intersection of 3.69. It says round to the nearest hundredth. 3.69. Okay? Notice it's 9.2, so it would be, just leave it there. Why don't we use y? Why don't we choose the y value? Yeah. Correct. In the equation it says solve for x. We've set them both equal to y, so okay. So solve for x. All right, the other one, if we calculate, everyone figure it out, please. And tell your neighbor what you got. Hey, 0.54? All right. Those are our two answers. Notice neither of those are extraneous because neither are negative in that case. Okay, they would both be fine here. Now, doesn't mean you're getting 2 answers on your quiz. It just so happens that this one gave me 2 answers. Okay, could have 1 answer. All right, any questions there? How do you feel a little silly that you missed that one? Yeah. Okay. All right, so just remembering it, you know, that's okay. That's what we're going through. So number 8, you deposit $1,000 in an account that pays 3.6% annual interest compounded monthly. Part A, when does your balance first exceed $1,200? In what year, or in how many years, and how many months? And Part B, use the compound interest formula to find the balance after this amount of time. So, first thing we need to do is we need to know the compound interest formula. Okay? So, I'm not going to give you guys enough time to write all that stuff down. But if you need the exact, I mean, the numbers are what's important and the work is what's important. All that stuff is the same type of wording as on your report. Okay, I just changed numbers. Compound interest formula. A equals P times 1 plus R over N to the NT power. That you needed to know. Okay, I expected you to have that memorized. So if you didn't, that's the first problem. Okay, from there, understanding that we want our new amount to be how much? I can't remember. 1,200. Okay, and we deposit 1,000. So our principal is 1,000. Our amount we want it to be is 1,200. Our rate was 3.6%, so make sure you change that to a decimal. Divided by the number of compounding periods, which in this case, if it's compounded monthly, that is 12. T stands for the time in years. Okay, so if we solve for T, we will know the time in years. So first step is to do the division. Second step is where some of you are making mistakes when I looked at your work and when I talked to you. Some of you right here brought that 1,000 in. Okay? And you cannot do that, right? This has to be raised to that power prior to multiplying by 1,000. So the next step is to divide by 1,000. Divide 1,200 by 1,000. Get 1.2, 1.00, or yeah, 1.003 to the 12t power. Okay? And then you take the log. You write it in log form, so it's log base 1.003 to the 1.2, or of 1.2 is equal to 12t. You then divide that by 12. Okay? And so, or actually I did change the base format for formula. And let me pause right there before I divide by 12. Are there questions up to there? Hallie? Okay, and I'll show you where the rounding problems are here in a minute. There are quite a few of you that had rounding problems, and I'll point out where those came in. Okay, so right there, and then you divide that by 12. So do not. So here's where one of the rounding errors could happen: is you divide this and you get a decimal and you round it. Don't do that. Put that whole thing into your calculator. Okay. That's one of the rounding problems. We find T. T is 5.072. Now that is a rounded number right there. And the reason I will round it right there is because, well, I went through and I just double checked it, but I know that when I do 5, that 5 represents years, that 0.72 represents a year. So 5.072 years. That means I will have 5 years and part of a year. 70, this would actually be 0.72. Okay, 72 thousandths of a year. Well, how do I figure out how much 72 thousandths of a year is? It depends what we're converting to. So are we dealing in quarterly, annually, monthly? Yeah, we're dealing with monthly, right? If it was daily, I would have to multiply that by 365. If it was quarterly, I'd multiply it by 4. If it was monthly, which it is, I multiply it by 12. And when I multiply by 12, I get 86 hundredths of a month. So even if I would have kept going decimal-wise, I still would have been right around here. 86 hundredths of a month is 1 month. Now, why don't I just call it 5 years? It is monthly, but like at 5 years, have I exceeded my $1,200? No, that doesn't happen until 86 hundredths of a month. Well, we don't do anything until the end of the month in this problem because it's monthly. Therefore, it would be 5 years and 1 month. Now, if this, just for the sake of what we're doing here, if for some reason this was actually 0.23 months, what would I make it? At 5 years, would I be over 1,200? No. It would still be 1 month, right? Because you have to understand when to round up and when to round down. Now, if they actually say round to the nearest month, then you would round down. because it actually says round to the nearest month or nearest whatever. Here it doesn't say that. It says when will it happen? Well, it won't happen until that first month after the 5th year. No matter where you're at, if you have any portion of that year, you're going to have to round up to get to that next month. Okay? So, that's where some of those rounding problems could have came in. Now, as lame as that seems, and as frustrated as some of you are with it, you're like, this is so stupid. Well, that's like real life math, dude. So if you think that's stupid, well, you're dealing with real life math. I'm sorry to tell you. I know. Yes?
I had rounded mine up and you got it wrong.
Oh, well, maybe you did something else wrong. Okay? I have to look at your work, Kai. You're supposed to have your Chromebook closed, though. So I know you're not looking at it. Okay, 5 years, 1 month. From there, we now have something we can plug our. So this was 5 years. This is 1 month. We now have something we can use to help us use the compound interest formula to find the balance after this amount of time. Now, some of you missed this part just because you weren't finding the balance after this amount of time. What amount of time? 5 years, 1 month. That's the amount of time now. Okay, so some of you just kept cranking away, maybe with the 0.72 here. Okay, you found an answer. You use that answer. We plug it in to our compound interest formula. In fact, I'm going to use it right here for you. Okay, I'm just going to go back to here because here's where I can plug in time. So you can look at part B if you want there, but we'll actually plug it in here. So you have A, so rather than the 1.2 now, okay, we would want, actually we'd have to have our 1,000 over here, so we'd have to use this one. Okay, so we'd have A equals, ignore that, 1,000, that's our principal, 1.003 times 12t. Now t is the 5 years, 1 month. Now how do I write 1 month in terms of years? Yeah, it's 1/12, right? And some of you are like, what? That I don't know how to do, like, how do I do 12 times 5 and 1/12? Well, some of you like use your calculator. I like to personally think that you know how to do 12 times 5 and 1/12 by changing this, if you need to an improper fraction. How many twelfths is that? That is 61/12. So that's 12 times 61/12, which is actually 61. So this power up here becomes 61. So 1,000 times 1.003 to the 61st power is $1,200.49. Okay, now a good question came up the other class. They were like, well, back when we were way down here, they're like, well, if I plug that in, shouldn't I just get 1,200? I did the math. I had it set equal to 12. Shouldn't it be 1,200? Why is it not exactly 1,200? Yeah, you went past it, right? We round 0.86 months up to 1 month. So you better have more than 1,200. You went for another 1,400ths of a month, dude. I mean, give me my 49 cents, right? I mean, that's what's happening there. Okay, so you need to understand what they're asking. I get that it's difficult, and I get that it's a computer asking you it. I understand all that. That's why I am allowing retakes, and I am going through problems with you. Okay? What I need from all of you is to make sure you keep good attitudes about it. All right? All right. Any other questions on that one? Last one is number 10. Now, this one I can understand a bit of the confusion, but let's go through it. Number 10, the table shows the number of y of flowers. Yes, of followers. Of followers. Maybe flowers would be better. But of followers a musician has on a social media website X days after opening an account. This is not my website. Mine has many more. Yeah, YouTube and math. Right. Okay. Okay. Use the points in which x equals 1 and y equals 5, or x equals 5, to write an exponential model for the data. Round your values in the model of the nearest whole number. Now, I saw that some of you actually put this whole thing into your stat menu and then did exponential regression, which is not what they're asking you to do. They're saying take this point and take that point and write an exponential function. In other words, they're asking you to do what we did on one of our assignments. Like you have the coordinate 120 and you have the coordinate 5, 234. Write an exponential model for that. Ignore all this other junk they gave you. That's what they're saying. Okay? Now, this is not an exact exponential model based on the data they gave us, but if you take 2 points, and you could definitely write an exponential model for it. Okay? And so what I've done is I've kind of went through the way we talked about in class. There are multiple ways. I showed work on some of the other ones, but this one, hey, I just took the 1 and 20, put it into a table. The 5 and 234, put it into the table. It said the common ratio, 234 divided by 20, is 11.7. How many remember doing this? Okay. You have went 1, 2, 3, 4, so you take the fourth root of that to find out you are actually increasing every time by 1.85. That's rounded to the hundredths right there. Okay? No, right there I just rounded to the hundred. Okay, I actually on my calculator I just left the 1.85 blah 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 on there. So I'm writing 1.85 here, but 11.7, taking the fourth root, it gives you a big long decimal. 1.85 is rounded for the sake of me writing it down. But when I actually divided 20 by 1.85, I divided 20 by 1.85 ... I divided it by the fourth root of 11.7. Okay? Which gave me 10.81. Why do I want that number? That is your a value in the form y equals abx. Now, a key piece that some of us overlooked here, or we did earlier, it says round the values in the model. What is the model? The equation. The word model represents an equation. You will see that term a lot. You've seen it in books a lot already. You've seen it on worksheet. Write a model for this data. That's an equation. So round the model to the nearest whole number. The nearest whole number to this is 11. The nearest whole number to 1.85, which is our b term, is 2. That is our model. Y equals 11 times 2 to the power of x. Okay? And then you plug in 10, which is what part B asks. Says, how many followers will there be on the 10th day? Plug in 10 to that model. So it says, use the model. It does not say, use the data from the table, because you'll get a different number. Use the model to predict after 10 days. Okay? Our prediction after 10 days, 11,264, based on plugging 10 in for x. Okay. Clarify a bit, I hope. Those were the 3 most common questions. Doesn't mean there aren't other questions out there, but those were the 3 that this class, over half of this class missed. Okay? Now, I did not go through each test and look at how many of you missed it because you said 1.85 here and calculated it. If that was your only miss and your only reason, I probably would have given you credit on it, like if you weren't going to retake it. But I do think it's important for you guys to be able to pay attention to detail and instructions. That's huge, especially if you're going to be future doctors and you're going to be operating on me at some point, or if you're going to be flying a plane, or for that matter, building a plane. Okay? That's pretty darn important stuff. You know, or any of that kind, I mean, those little details are big deals, right? Yeah.
It's like almost engraved in my brain. I like to round, like everything I do, all the steps, like my brain like wants to learn it, and I do, even though it's said like in the model. Like, it's just like, it's almost like muscle memory. Like I've been taught how to do that like my whole life. It's so hard to like do it. Just figure it out.
Yeah, that happens. So maybe circle and I don't know. Maybe you have to cross your fingers every time you see the word round. I don't know. All right. Any questions? All right.